Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group, and we try to help people get started into using Python, and also do some sessions on machine learning. Arun would normally do the machine learning sessions. I'll normally do the Python sessions. On the first week of the month, we try to do something that'll cater for absolute beginners, so that's what we're going to be doing today. And we're doing this as a live stream, which has the advantage that you can ask questions along the way. So I'm going to be watching YouTube chat, and I'll be watching the Slack channel. So let me know on those if you have any questions or comments about things. And remember, absolute beginners, so it can be even the most trivial questions about Python, and that's what we're looking for. And no doubt someone else will have the same question as you if you do have that question. They just might be too afraid to ask. So we're going to be running the session on Google Colab, which means that you don't even need to install Python on your computer. And Google Colab's a very powerful environment, provided free by Google. They do have a pro version, but I've never needed it. And it gives you a virtual private server running Ubuntu Linux and Jupyter Notebooks, which is a sort of interactive Python. It's just the normal Python with some interactivity added on top of it, and it's a great way of learning Python, and it's even great for data scientists who want to use Python in their everyday work. So to go to Google Colab, I've provided a link to a notebook that I've created. If you look down below the video, you'll see it in the description of the video that you're currently watching, and it's on the meetup site if you're on the meetup site. So I'm going to click on the link to colab.research.google.com, and it will open up so you have to open up a new tab if you're watching or a new window if you're watching it on YouTube video. So this is the notebook that I've created. It says changes will not be saved, but you can make a copy of it. And to do that, there's a nice big button here, copy to drive. So I recommend, if you've got your own Google account, then just click copy to drive, and it'll make a copy on your Google Drive, and that way you can make changes and save them as well as just running it. So I've got private output, so it doesn't save the answers. And I'm going to click on connect here in the top right, so that it gets the virtual private server up and running and save us a little bit of time. So our learning objectives today are to how to use interactive Python. I'm going to give you a bit of an introduction to coding, just what does it mean to write a program, and we're going to be doing it in Python. So some of the features of programs are branching, looping, list, and list comprehension. There we go. That's going to be a bit more advanced for a beginner's topic, but let's do it. So challenge one, get the software running on your computer, and because we're using our Google account, we've got the link, so if you're here, then you've achieved challenge one. But you can run it you can install Python on your computer. Now even that is not a trivial question of how do you install Python, because there are so many different ways of installing it. So I recommend the Python that is provided by python.org, and they're the people who wrote the original Python, and they give you a standard Python. So it's all very standard, and so it should work very well for you. Alternatively, you can install Anaconda, which includes a lot of third-party libraries. So they've discovered that people who wanted Python also wanted some extra libraries that go along with it, and some of them were a bit hard to install, so Anaconda made that a lot easier. But it's these days the third-party libraries install really well, so you don't need Anaconda. Anaconda's hasn't got such an open license as the standard Python. So standard Python is free open source software for everyone to use. You might also want an integrated development environment, such as PyCharm's the one that I use the most. A lot of people also use Visual Studio Code, so I provided a link there. But we don't need to do any of that because we're using Google Colab. And now I've just written here some of the differences between the different ones. So Jupyter Notebooks, which is what we've got here, is an extension of IPython, which stands for Interactive Python. And I've also got, so this is a notebook version of today's script, and there's also a Python script version of the script, which doesn't have the interactive features in it, and you can find it on our GitHub site. So what is Google Colab? It's a series of cells, and you see if I click on that cell, it's put a blue border around the cell, and if I click on the next cell down, it's put a blue border around that. Now the cells can be different types. They can be text or code, and you see if I hover between them, I can add in a new code cell or a new text cell just by clicking on the button. And you can do that as we go through the session today, and you can create new cells and try different code in the cells that you can type in and get a real feel for how Python works. So this cell at the top is a text cell. This next cell down is a code cell, and the code cell is using Python as the language. I think there's a setting for that somewhere, and in the runtime we can change what language we want. There's so Python 3 or R or Julia you can run in notebooks. And it does syntax coloring. So here I've started by showing some Python code, which is just the comment. And now a comment in your code is just a bit of text that you can write down to make it easier for you later when you come back and read your code, or for someone else who's reading your code to understand what it does. And comments in the code, they start with this hash symbol, and they don't do anything. And if you see them, so you can just read them. And I put a comment here explaining how to get help in interactive Python, and you can do that by using the question mark, and there's the question mark as an example. And now we run that cell by pressing on the play button here, and in IPython that'll bring up the help, which comes up here on the right, and then that'll give you some more help about other ways you can use this question mark. You can put a name of an object in the question mark or a double question mark, or you can use this %quick reference to get a quick reference to some IPython specific syntax and magics. But I think that's all we'll do for now, so I'll just hide that. But if you're looking for help, that's a good way of doing it. If you're not using IPython, Python itself comes with a help function called help, so you can just type help, open close parentheses. Okay, so coding is all about writing a command for a computer to follow. So we're just instructing it what we want it to do. So the only commands a computer can do are rather simple, but it can do them very, very quickly, and it can do a lot of them. So if we want to display something, we'll use the print command. So if we want to print the number 5, we take print, open parentheses, the number 5 and close parentheses, and when we run that, it displays the number 5. So that's standard Python does that. In interactive Python, it can be even easier. If you're in a cell like this, you don't even need to use the print function to display data. You can just, the last line that's in the cell, it will, if it has a result, IPython will just display it. So here I've just put 4, and it displays 4 by running that. So you can run this on your computer as well. So every time I click the play button, you click the play button on your computer as well, and you'll should get the same results. Now, commands in a programming language like Python are executed sequentially, so one after the other. So we've got two commands here. We want to print 4 and then we want to print 3. So if we run this cell, we'll get the number 4 displayed, then a new line, and then the number 3 displayed. So that's pretty nice. We can print out reports and stuff just by using lots of print statements. Unfortunately, in IPython, only the data on the last line in a cell is displayed. So if you want more than one line to display, you do need to use print even in IPython. Just as a demonstration, you see just the one shows up. All right, so here's a task. I'm going to set you a task, and I've given you an empty cell here to put the answer in. And so you can type it in. You can decide to pause the video and then play it. Just find out, then I'll do the solution for you. Or you can try to do it as quickly as I do it. And so the task that I'm giving you here, in this empty cell below, write a Python program to count down from 5 to 0 on separate lines. So you've seen that we've used the print function to do some displaying numbers, and we can do that again just with a bunch of print statements. So we'll say print 5, and AI keeps jumping in and trying to print a solution, but it's been looking ahead, so it's getting the wrong answer from what I'm going to do. Now it's getting a bit of a better idea, although I lost it. I don't know why I lost it. To 0. Okay. So there I've done 6 print commands. They're all going to be run sequentially. Let's run it. 5, 4, 3, 2, 1, 0. And so that's the solution to the task. So I'm just trying to make it easy to get started and give you a bit of confidence that you've learned a Python command and you can type it in and get a little Python program to run. Now I'll provide a solution, and in the solution I like to show something different, maybe that you haven't learnt yet. And so this one will run the solution, and you can see it looks a bit different. And it's displaying the numbers as words, 5, 4, 3, 2, 1, 0, and a bit of text at the beginning saying what the solution is. So when we printed out these numbers, we didn't need any quotation marks around them, but when we want text, then we have to put quotation marks around it. And these text with quotation marks around it, they're called strings because it's a string of characters. And so we're going to use strings quite a lot in our programming, and that's how you do a literal string. The letters FIVE, put quotes around it, and then when you print it, it will come out as those letters, FIVE. All right, solution 1 shows an alternative way of solving task 1. It shows that when using print with text rather than numbers, we need to surround the text with quotation marks. Yep, and that is a string. Okay, now here's another function called type, T-Y-P-E, and it'll tell us what the data type of some of the data is. So if we put our string in here, ABC with double quotes around it, and say what's the type of that, it'll tell us it's an str, and that's the way Python denotes strings. Similarly, if we put a number in there, 1, 2, 3, and say what's the type of that, Python will tell us it's an int. And int is short for integer, which is like a whole number, so it has no fractional part. Remember to ask me any questions if any of these words that I'm using don't make sense. Now here's another number I could put in, 123.45. Now it does have a fractional part. So when I ask for the type of that, Python stores that number as a float, which is short for a floating point number, which is like a real number. Python can do arithmetic on operators using operators. So the operators, standard operators are plus, dash, asterisk, slash, double slash, %, and double asterisk. And so see if you think of what they all do. The plus is for addition, the dash is for subtraction, asterisk is for multiplication, slash is for division, double slash is what they call floor division, which is will have an integer result. So you use double slash if you were dividing two integers and you wanted the result to be an integer, and it will have an integer result, but it'll also be a remainder. If you want to find out what that remainder is, you can use the operator percent. And then the last operator there, asterisk asterisk, that's to the power of. So 10 asterisk asterisk 2 will be 100, because it's 10 squared. So we can just write an expression here, an arithmetic expression with using those operators, and it will calculate the answer for us. So we can use Python like a bit of a calculator, and it has for integers it can store as many there's no upper limit on the size of an integer. For floating point numbers, there is a limit to what resolution it will have. It'll only go to about 17 decimal places, but for the integer you can go even more than that. But I mean, not in decimal places, but in numbers, significant figures. All right. Once we've done a calculation like that, you might want to save the result into memory. And so we do that by using what's called variables. So we name our area of memory with a name. So we can say A equals 5, and that'll put the number 5 into a memory location that we've called A. And then later on, whenever we want to say what's in that memory location, we can just refer to it by its name, A. So for example, we want to print what's in the memory location A, then we just say print A. And I think now you can see why strings need the quotation marks. So Python can tell the difference between a string and a variable name. So if it doesn't have the quotation marks, it's a variable name, like this. If it does have quotation marks, it's just a string. So let's have a look at some more operators and more memory locations. We can store 2 to the power 32 into the value b, and then we can multiply a by b. So these are two variables, a and b, that we've, remember a is the value 5 and b is whatever that is, and store the result in c. So we're printing a, b and c, and we've printed them all in the one print statement there. So it's and we just put commas between them, so Python's just put a space in between when it's displayed them. So the number 5 is an integer. This number here is about 4 billion, and so that's the size of a 32-bit integer. And I always remember that the way I remember how big 32-bit integers are is that they can't store the population of the world. So if you want to store the population of the world, you've got to go more than 32 bits. And I think the population of the world's, well, last I checked it was 7 billion, but it's probably up a lot higher than that now. And then 5 times that is this much. And that's why when you've got a 32-bit computer, you can only access 4 gigabytes of RAM. And if you want to go more than that, then you need to go 64-bit. So you can see these numbers have a significance for us. Now, programming would be very cumbersome if we had to type a line for every command we wanted to execute. So repeated commands, you can put them into a loop, and so it'll just keep repeating the command. That means we don't have to type it. So remember before, when we wanted to print out the numbers 5 to 0, we had to do 6 print statements. Now we can just put them in a loop, and it would just be basically 2 lines saying I want to loop through these numbers and print out the value every time. So I'll run it just to show you what it looks like, the output, and you can see 5434210 as before. And I've also put in a total here, so it's summing up the values every time it goes through. And this operator plus equals means add to the current value. So we started off with total equals 0, Z is 5, gets added in 4, 3, 2, 1, and the total of all those numbers is 15. So the loop here is started by the for command. So we've got for, and for will have a variable name that is going to change every time it goes through the loop, the value of that variable. And then we put a sequence of values that we want it to have. So the first time through it'll have the value 5, then the second time through it'll have the value 4, then 3, then 2, then 1. And that'll go into this Z variable, and then the value of Z will get added into this variable total, and then it gets printed out. Now the code block of commands that are in the loop are all the ones that are indented, and the tradition is to, or convention is to, indent by 4 places, and they're in, so they will run every time, those commands. But this line here is not indented, so it only runs at the end when it's finished doing all the loop. The other important thing is whenever you start, if you've got something that's about to start a code block, which is a group of code, you'll start with a colon, and then it's expecting the next line to be indented, and we'll keep all the lines of code together that are indented the same amount. If they're indented further, then you would be starting a new code block after this one, and you can have code blocks within code blocks by doing that. But you don't have to have any special character for ending. All you do is just remove the indentation. And that makes Python a much cleaner language to read than other languages like Java or JavaScript or C that have curly braces or something at the beginning and the end of code blocks, and their indentation is not essential to be right, so it often the programmers can get lazy and not put the nice formatting on the indentation. But for Python it's so important to get the indentation right that programmers have to get it right, and it actually makes the code look nicer when you're reading it. And so that was one of the primary design goals of the Python programming language, was to make it easier to read. So I've got any questions about that? Are people successfully running this code and getting the results? All right, so now, anyway, we'll set another task here. Task 2, rewrite the loop to show running total as it loops through all the numbers. Okay. So that's pretty easy. I'll just put in here that in our print statement we're printing the number, and let's also print the running total. And run that. There you go, 5, running total 5, 4, running total 9, and you can see how it's incrementing as it goes along. And so that's a good way of checking on your code that it's running, just putting a few print statements in there, so you can see that the calculations that are doing it are that it's doing it correct. So I've got a solution here, and it's going to use a different sort of loop. It's going to use the while loop. So remember the for loop, we've got a variable here and then a sequence of values for that variable. In a while loop, we just have a condition. So the while says while this condition, so it's going to check whether it's true or false, that condition. And while it's true, it'll just keep looping and looping and looping. So you've got to make sure that something inside that loop is going to change the value of this expression. And the way we're going to do that is we're going to change the value of Z, and we're going to reduce Z. So Z minus equals 1. Every time it goes through the loop, Z will reduce by 1, and that means that eventually Z will no longer be greater than or equal to 0. So I'll run that, there's the answer, and we get the same output. The number is 5, the running total 5, the number is 4, running total 9. because each time through it said started at 5, which was the initialization before the loop, then in the loop, and you can see the colon here says we're about to start a code block, an indented code block, and then we do our summing of the total and our print commands. This makes it really easy if I wanted to, say we'll start from 15, and there we go. Well, if in the for loop here, I'd have to go 50 down to 0. So that's one advantage of the while loop in this case. There are other ways of doing the for loop, but we'll get onto them later. Okay, task 3, write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. So factorial is 1 times 2 times 3 all the way up to, in this case, 5, and display the result. Okay, well that's going to be pretty similar. We can just use a for loop for this. So I'm just going to copy and paste. So we'll have our factorial. Now we should we have to start by 1. If we start with 0, then the result's always going to be 0. So we can't have a 0 in our list, our sequence of numbers. So let's use the sequence this way, and we should count from 1 up to 5, but it's going to be the same as if we count from 5 down to 1. So yeah, maybe we'll swap the order around, so we'll get the intermediate factorials as we go. And I've got to change the equation. So 1, running factorial is 1, 2 is 2, 3 is 6, 4 is 24, 5 is 120. So factorial of 5 is 120. Okay, so let's have a look at the solution. Looks pretty similar, except rather than having to type in all the numbers, it's used this range function. And so they worked out that it's pretty common that you'll want to go have a sequence of numbers and they're all just incremented by 1, or even range actually has an ability to go up in 2s or 3s or some other step. And so they've got the range function, which you can use in this for function, and in this case range goes from 1 to 20, and you can see the factorial there growing very, very large as we go up. Now, one thing to notice is that range goes up to, but not including the last number. Now, the advantage of that is that you can always quickly calculate how many times it's going to go through the loop by subtracting the first number from the last number. So 20 minus 1 is 19. It's going to go through the loop 19 times and give us an answer. So if you wanted to find out the factorial of 21, well, if you wanted 21, then you'd have to go up to 22 here. And there's the answer. So that's a pretty standard convention in Python to go up to, but not including the final number. There's just a couple of places where it doesn't do that. Maybe like in the third-party library, Pandas has got a couple of places where it doesn't do it, but most of the time it will. And by being consistent, then you know what it's likely to do. Task 4, display the first 20 numbers in the Fibonacci sequence. So if we start off with f1 equals 1 and f2 equals 1, then f of any index is going to be the previous number plus the number 2 previous. So for example, 1 plus 1 is 2, 1 plus 2 equals 3, 2 plus 3 equals 5. This is the Fibonacci sequence. So let's write some code that can do the Fibonacci sequence. So we can call our variables things like f1. So let's call that f1 equals 1, f2 equals 1, and we might let's call it fn1 and fn2. And so fn1 is really this this number here, and fn2 is this number here. We can't put a dash in a variable name because it'll think it's the minus sign, but we don't need it. We can just do that. And then we can say fn is equal to fn1 plus fn2. That's right. And then once we finish that, then we're going on to the next value of n, so we have to step back the previous values. So we can say fn 2 equals fn1, fn1 equals fn. There we go. AI is sort of getting it for me. So how about we can print those three numbers. Print fn2, fn1, and fn. That'll do. fn2, fn1, and fn. And then we want to loop that. So we want to go through the loop. So the first 20 numbers in the Fibonacci sequence. So that's printing 3 numbers. And so let's loop through that 20 times. For I in range 20, so that'll go through 20 times. Do that code block. So there we can see our Fibonacci sequence: 1, 1, 2, 3, 5, 8, 13, 21, 35, and it goes down. Now we've because we've got 3 numbers in the first row, we don't actually want to go through 20 times. We could just go through 18 times, and that'll give us 20 numbers. All right, so do you understand that code? We've got a comment here from Sebastian saying something's on fire. I hope it's his coding's on fire as he's going through this task. So let's have a look at the solution. Now you see in my solution I needed 3 variables so that I could swap fn1 into fn2 and then fn into fn1. But in this solution, there's a thing you can do in Python where you can do multiple assignment statements on one line. So I can put a few variables here on the left, f1 and f2, and then on the right I can put the values that I want them to have. So they can be 1 and 1. And then as I go through my loop, I can say f1 and f2 equals f2 and f1 plus f2. So f2 goes into f1 and it calculates this before it does the assignment. So f1 plus f2 then goes into f2. And that means that I can do this whole code block with one less variable. And if I print it out, and it gives me the 20 values of the Fibonacci sequence, which you can see are the same as I got. We've used a technique in the print statement to say at the end of the print, after I've done the print, rather than do a new line at the end, just give me a space. So it's printed it, then left a space, printed, then left a space. And then right at the end, I just wanted the last 2 values, and it will do a new line after them, and that's printed them there. So this is a pretty common example of how to do Fibonacci sequence in Python, because it does show this multiple assignment statements on one line, and one of the advantages of it. Okay, so let's have a look at task 5 here. Counting down in steps of 2.25 from 10.5 to -3 inclusive. Okay, so you might remember if I can use the range command for I in range, and so if I wanted to start from 10.5 and go down, what is it, to -3, minus 2.25 is the step, print I. Okay, I, and I run that, and then I get an error, and it says that I can't put non-integers into here. So that's a bit of a shame. But what I could do is I could use a while statement instead. So I could say I equals 10.5 while I is greater than -3, print I, and then subtract 2.25 from it. And then, yep, that'll work. How do I accept this? I was going to just accept the, oh yeah, tab worked for that. So we'll take the AI solution. And there it's done it for us, and that all looks very good. So let's look at the solution. The solution's using the range command, and what it's done is it's worked out the lowest common denominator of our numbers. So 10.5 is 21 divided by 2. 2.25 is 9 divided by 4. So the lowest common denominator is 4. And so I could multiply everything by 4, use the range function with integers, and then divide all my results by 4. So that's another way of doing it. And I'm also showing you there how to get some nicely formatted output. So I'm using these F strings. In the F string, you put an expression inside curly braces, inside the double quotes. So I'll explain the anatomy of an F string. You put an F, then you put double quotes or single quotes to do your string, and then inside those quotes, wherever you've got curly braces, it will produce it'll evaluate the expression, and our expression is x divided by LCD, the lowest common denominator. And then you could have a colon, and anything after the colon is the format. So we want to format it as 7. The width of the field that we're printing is 7. We want to show a decimal point, and then after the decimal point, we want to show 2 decimal places, and we're going to be printing floating point numbers, which is what that F stands for. And that's how we get this nice, nice looking string. And I could put some just like literal text in there as well, and say counter 10.5, counter 8.25, and it counts down. All right, so that was an example using a step of 2.25, which you might think, well, that's a fairly complicated step. But it turns out to be a lot easier to do 2.25 than it does to be able to step down in 0.1s. So here's an example where I'm going to use a while loop, and every time I go through the loop, I'm going to subtract 0.1. And the reason this is a problem is that 0.1 is difficult to represent in binary. And so every time you use it, you get a slight floating point error. Now, for the first couple of times, Python does a reasonably good job of going, that's just the floating point error, we won't worry about it, we won't worry about it. But finally, the error gets so bad, Python goes, oh, I think I need to display it. So it displays the difference, because it can't tell whether that should really be 0.7 or 0.7, all these zeros and then a 1. So it displays it, and then by the time it gets down to 0, you can see that's the magnitude of the error that's built up, so by 10 to the minus 16. It's a small number, but it throws out all our displays. So if we did this using the lowest common denominator technique, that would avoid the problem. So once again, we go into integers and we divide by the lowest common denominator, which is 10, and we can see that printed out in 0.1s nicely. So that's one way of doing it. There are others. We're not going to look at them now. Okay, more data types. So list is a data type. So remember, we've done integer, floating point, we've done strings, and now we're going to do lists. So lists are surrounded by these square brackets, and they can be an ordered collection of data values of any type. So I can create this list and then I can print it. And when it prints the square brackets, commas, and then what's in between. So we can create a list by aggregating values into it. So if I go through this loop 30 times, and every time I add in 2 times the value of x and create my list, and you can see there's 30 values in that list going from 0 to 58. So I've set a task here, create a list of numbers from 20 to 0, stepping down by 4 each time. Okay, so we'll create an empty list, and we call it anything we like. So maybe I'll call it L, so I don't clobber my previous list name. And we're going to go a list of numbers from 20 to 0, stepping down by 4 each time, and then I'm going to append a value into my list, and then I'll print it out. And it looks like the AI got it right, so I'll press tab on all of that and run that. Okay, so there's my list. Now it turns out this is a pretty common thing people want to do, is have some sort of iterative range that they're going over and then just compiling all these things into a list. And so Python created a thing called list comprehension. So we can use the list constructor and take any iterable value, and range is an iterable value, just stick that in there and it'll create the list. So if you start to do put these iterable values into a list constructor, well, that will impress people if they see you doing that. So that's using a list constructor. Now say we want to put a list of square numbers from 0 squared to 10 squared. We can't use the range function to do that. So we'd have to go back to our old ways of doing a defining the list first, then having our loop, x in range 11, yep, then append x squared, and then print. And 0, 1, 4, there's our list of squares. But Python have provided us this thing called list comprehension, which means we can, because this layout is so popular, then we can have our function that we want to append into the list. So we put that first, and you see how we put this all in square brackets for a list. So I squared, and then this our loop for x in range 11, and here we say for I in range 11, and it creates the list. So those 3 lines have been compressed into 1 line. So if you're doing it a lot, that's great. A great way of really shortening your code. If you're not doing it that much, you might, and you don't remember this syntax, then maybe use the more verbose way, because it's clearer what you're trying to achieve. All right, so we've done, that's a list. There's another data format called a tuple, which is a sequence. We've used it before in our for statements. We want to create a list of tuples, I to I squared, from I equals from 0 to 10. All right. I'm just going to jump straight to the answer because that's all I'm going to do. So that's what we want to store, I comma I squared. Here's our loop in our list comprehension, and then we'll stick it all in a list. And so if we print that, we can see we've got 0 and 0 squared, 1 and 1 squared, 2 and 2 squared, 3 and 3 squared, 4 and 4 squared. Difference between tuples and lists is that tuples are read-only, and lists you can actually change them in place. But apart from that, they're pretty much interchangeable. Anywhere you can use a list, you can use a tuple, and most places that's if you don't need to change it. Anywhere you can use a tuple, you can use a list, except if it's a place that requires what they call an immutable data type, and tuples are immutable. All right. So we've done looping. Now we're going to do branching. And branching, we use conditionals. So an if statement is how we branch our code. We look at our conditional, which we did conditionals before with our while loops. We check if something is true. If it's true, it runs that code. Otherwise, we can do an elif, which stands for else if. We do another check. If that one's true, then we run that one. Else, which means if none of the above are true, then it falls through to this one and it will run that. So we can say we're going to check each number between 0 and 10 and see if it's divisible by 3. And we see, so 0 is divisible by 3, 3 is divisible by 3, 6 is divisible by 3, and 9 is divisible by 3. 1 is one more than a multiple of 3, and 2 is one less than a multiple of 3. So that's an example of branching in code. Okay, so our task is here, create a list of numbers from 20 to 0, stepping down by 4 each time, excluding the numbers divisible by 3. Great, so just when we thought we could use list comprehension for this sort of thing, suddenly we get something a bit more complicated, and we have to go back to our verbose way of doing it, and we'll take the AI for x in range. It's going to go through that range starting from 20 down to, and it's gone down to -1 because we want 0 included. Stepping in -4s, check if it's divisible by 3, and if it's not, then we append it to the list and print the list. And there's our list, so we can see it included 20, 16, but didn't include 12, then it included 8, and then 4, but not 0. But here in the solution, there is a way of doing this using list comprehension. Because this format is also popular, and the way you can do that is by putting the if command here after the for command. So we say our variable or expression, our loop, and then our condition, and then that's what our list is going to be constructed of, and we see we get the same answer. So now we're going to do something a little bit more advanced because we're feeling confident, and we're starting to get the hang of this. So you've seen we've used the range function in our for loops, but what does a range function return? So let's call the function and put the result into our variable called r, and then print it out. And it prints out a range object. So we put in range that, and that's what we get out. So if we let's get rid of the for and see what we get out. Oh, yep, it knows to not include the for. That's pretty clever. Okay, so then we can create our list object from R, because R is a range object, and we can just pass it into the constructor for list, and it'll now evaluate it out. So it goes from 3 to 14, not including the 14, stepping up in 4s, 3, 7, 11. So with that in mind, here's an advanced task to see how well you've picked things up today. Rewrite the following code using nested loops. So we're going to have all these range functions, and we're going to run the for loop, and we're going to print out, we're going to use them to print out different results. So we'll say range 4 gives us 0, 1, 2, 3, range 2 to 5 gives us 2, 3, 4, 3, 14, 4 gives us those. Okay, now we can see there's a lot of duplicated code in patterns there. So how would we, if whenever you see repeating code like that, then you think maybe this is a place for a loop or a function or some way of removing repeated code. In fact, there's even a programming mantra called DRY, D-R-Y, don't repeat yourself. So if you see code like this, then you go, actually, there's probably a better way of doing this. And one of the reasons is that if you're copying and pasting code to make this, you might get one little bit slightly wrong, and you're not going to notice it, and then you're going to have a bug in there that you won't see. But if you only have it once, you only have to study it carefully, make sure the bug's not in that bit of code, and then you know it's right for when you repeat it over and over again. All right, so let's grab, so these are the ranges that we're going to use. Yep. So I just can't see them on the screen at the same time. So let's copy and paste, and we'll start coding down here. So what I'm going to do, I'm going to create a list of ranges. So I'll say list of R equals, and we'll open it up. And let's just do that. And this way I can put all of them into my one list. Okay, and then for R in LR, then I'll nest my loops. So I'll do, because I'm nesting them, I'll do double indentation and run that. And so there we go. I've got 0, 1, 2, 3, 2, 3, 4, 3, 7, 11. So what I'm not getting is the name of the range to start with. So maybe I can do that as well. Yep, that'll work. Range 0, 4 gives me 0, 1, 2, 3, 2, 5, 2, 3, 4. Okay, so there's a solution. Now, if we're looking at the solution that's provided here, solution 10, this is another way of doing it. Rather than store all the ranges, we just store these as sequences of numbers. So I've used lists for my sequences here. So I've got a tuple of all these sequences, a tuple, I should say. And so every time it goes through that, the range args will have a different value. So the first time through it'll have 4, second time through it'll have 2, 5, then 3, 14, 4. And then I can create my range object using all the arguments in my sequence. And you can see this asterisk at the start here. This is getting advanced stuff. But, you know, if you like to throw in a couple of advanced things so that you can impress people if you need to, and you go, okay, I'm going to put an asterisk in here so I can explode out all my arguments in my sequence and create a range function that way, and then I can print out the result. So let's do that, and I get the same results as before, and it's using I didn't have to store ranges. All I had to do was store these sequences of numbers that were then used as arguments to the range function. Hope that made sense. I hope you learned something from what we've gone through today. So remember to subscribe to the videos. I've got a lot more other sessions that I've done. You can check our GitHub site to look at so this is the GitHub site. Check some of the other sessions that we've done. The ones that have got Tim in the front, they're the ones that I've done. And every one of these has got some links to a video and maybe a Google Colab, or this is a Python script, so you can see here in the most of these in the GitHub are Python scripts. The one we're going to be doing in a fortnight's time, this is going to be how to use Django, which is a framework for building web applications, and we're going to use it with Strava authentication. And so you'll need to have Python installed on your computer to run this one. But it'll be a lot of fun. It'll take us a few weeks to build the entire Django web app, but it's nice to see something built right from scratch rather than just the snippets that we're doing in Google Colab. So if you think you're up to that, then I'd recommend this one. We've done Meetup 206 a while back, was using Django, and for authentication there we use Google authentication. So I thought I'd try Strava authentication, which is a much less common way of doing it, and it certainly threw up a few changes of how to do it from the Google way, but it also gave us the ability to get data, extract data out of the Strava application, and we can look at people's running activities and see how they've been going over the year. Okay, well, that's all, and I'll talk to you in a fortnight's time.